so this is the first part of section 9.5, and this is on trig equations. So I'm just going to dive right into it, okay? Solving a trig equation is just like solving any other equation. The goal is to find the value or values that you can substitute for the variable that will make this statement true. So what this is asking you is the tangent of what angle or angles is root 3. Now this is one that's pretty straightforward, all right? So this root 3 might be one that you recognize, it might not. Normal equation solving techniques here would say that you need to get rid of the tangent. Now, of course, that's not multiplication, so you can't divide both sides by the tangent. Instead, what we're going to do is take the inverse tangent of both sides of this equation, because this inverse tangent of this tangent would just give me x. And then we have that inverse tangent of root 3. Because I want my solutions to all be on the interval from 0 to 2 pi, that one revolution, just using the calculator on this isn't going to be enough. And that's because of the domain restrictions on the inverse tangent function. So if I just go straight to the inverse tangent of the square root of 3, and this may be one that you recognize, I've asked you to memorize certain ones, you get 60 degrees. That is the quadrant 1 angle. So what this tells me is that the tangent of 60 degrees is root 3. Now here's the issue. The calculator's only going to give you this one answer. There are others. So remember, when we think about, what's positive in which quadrant, the tangent is positive here and here. So we have this 60-degree angle here in quadrant 1, whose tangent is root 3. There's also an angle in quadrant 3 down here, whose tangent is also going to be root 3. And it's that 60-degree reference angle. I know it looks like 45 degrees. I just kind of slapped it down really quick. That 60-degree reference angle in quadrant 3 is also going to have a value of root 3. So we know that that's 180. So 180 plus 60 here is going to be 240 degrees. So my two answers are going to be 60 and 240. Now let me write that a little bit nicer for you. 60 degrees, we know the tangent of 60 degrees is root 3. We can also get this from the calculator. The tangent of 240 degrees is the positive tangent of 60 degrees. That's me taking the quadrant into consideration and the reference angle. So this quadrant 3 business comes from this ASTC business, and that reference angle of 240 degrees is 60 degrees. Now, here's the thing. These two angles, both of them, if you check this in your calculator, the tangent of, now make sure you're in degree mode when you do this, but the tangent of 60 degrees is square root of 3. If I do the square root of 3, you can see those are the same thing. And then, of course, the tangent of 240 degrees, also same as root 3. Any angle that is coterminal to these will also work. So, for instance, if I take 360 plus 60, and I get 420 degrees, let me scooch this over a little bit because of the glare. The tangent of 420 degrees is also the square root of 3, because that 420 degrees is coterminal to 60. So that gives us a problem. When do I stop? Like, how do I stop? If I can just keep on adding or subtracting 360 to these answers, how do I know when to stop looking for answers? Well, that's where this interval comes in. This says, hey, we're just looking on one revolution here. So all of our answers are going to focus on just within that one revolution, so you don't have to worry about those coterminal ones there. Now, what I said earlier, I wrote this a lot nicer because I just kind of scribbled this down, but this is a lot nicer, that if you take the inverse tangent of both sides, you get this inverse tangent of root 3. The calculator is only going to give you this one solution. That's because way back in chapter 8, I think it was, when we did the inverse trig functions, the inverse tangent is restricted to quadrants 1 and 4, is it? Yeah, I think it's 1 and 4. Yeah, 1 and 4. Negative pi over 2 to pi over 2. So because of that domain restriction, your calculator's not going to give you that other answer of 240. But it'll give you enough to get you started. So the key here is that, hey, I can use the calculator to kind of get started, but you're going to always have to come back to this quadrant business, reference angle business, to find the remaining angles. Okay, so let's look at a different one here. So very similar. This time though, you'll notice that I put a negative in front of the root 3. So we want to find all the angles whose tangent is negative root 3. Now this is going to be very similar to the one we just did. We just have to focus again on the quadrant. This root 3 for tangent, this thing right here, is telling us, hey, you're going to have a 60-degree reference angle. And this negative right here is saying that 60-degree reference angle, where is it going to be? It's going to be in the quadrants where tangent is negative. And that's going to be quadrants 2 and 4. So thinking about putting a 60-degree reference angle in quadrant 2, knowing that that's my 180 kind of checkpoint there, that's going to be 120, and then putting a 60-degree reference angle over here in quadrant 4, that's going to be 300 degrees. So I get 120 and 300. So you're going to really, how I said that with test 1, it was super important that you guys understood things like reference angles, coterminal angles, this quadrant business, what's positive, what's negative, things like that. And also with some of these, it's going to be really helpful to kind of already know some of these. If you just recognize, like first thing, that root 3, and you're like, hey, I recognize that's as 60 degrees, then you just have to think, where do I put this 60? Let me show you real quick what happens if you use the calculator on this one, because it's a little tricky. If you do the inverse tangent of both sides of this, of negative root 3, you get, oops, a big glare, you get negative 60 degrees. Notice that neither of those are my answer. That's because our answers are all going to be on the positive 1 revolution from 0 to 2 pi. That's not an angle between 0 and 360. Yeah, so 0 to 2 pi is the same as 0 to 360. But negative 60 is coterminal to 300 degrees. This is because the domain restriction for tangent, for inverse tangent, is quadrants 1 and 4. So the calculator is going to give you the answer in either 1 or 4, depending on if it's positive or if it's negative. because this is negative, the calculator gave me this answer, but it gave it to me as a negative 60 degrees. So the calculator, again, can be helpful. You just have to know if you get a negative, you're going to have to add 360 to get that coterminal version of it. So there's one of our answers. But you can at least rely on the calculator to give you the reference angle. You know, so that's kind of what I use the calculator for, kind of as a guideline there, to at least help me get that reference angle. Okay, so let's look at another one. The cosine of theta. Now this time I used theta instead of x. It doesn't matter what variable you choose. And that's equal to root 3 over 2. That's one that you might recognize. So the square root of 3 over 2 might be one that you're like, hey, that's one she had me memorize. Okay. If you were to take the inverse cosine of both sides, you would get theta is the inverse cosine of root 3 over 2. So that's taking the inverse cosine of both sides gets rid of this cosine. Don't divide. That's not multiplication. So you can't divide by cosine. So if I take the inverse cosine, a little bit, of root 3 over 2, I get 30 degrees. Now, when you're doing these on the calculator, make sure that you're in degree mode. You don't want to be in radian mode for these. All right, so I get that theta is 30 degrees. There's one of my answers. That one's in quadrant 1. So now you have to start thinking, okay, we're back to this business. Where's the cosine function positive? Well, here for all and here for cosine. So I need 30 degrees in quadrant 1, done. And then I need 30 degrees down here in quadrant 4. So that's going to be, well, that's 360, and I back up 30, that's going to be 330 degrees. So this, I started with, okay, let's say that you recognize that cosine 30 degrees is root 3 over 2. Then you already know, hey, 30 degrees is one of your answers. This is telling you which two quadrants to put it in. In quadrant 1, easy. The reference angle is the angle. Quadrant 4, 30 degree reference angle is 330 degrees. If you don't recognize this yet, if these have not quite stuck in your head just yet, well, the cosine of 30 degrees being root 3 over 2, you can find this by doing the inverse cosine of root 3 over 2 to get that 30 degrees in the calculator. So these are kind of your two scenarios. Like, if you recognize it, you move forward. Awesome. If you don't recognize it, it's okay. You're not just out of luck here. So you can see that our common theme here seems to be that there's going to be two solutions for each one of these. And for a lot of these, that's true. There are some special cases, though. So there's no hard and fast rule of, hey, there's always one solution, there's always two solutions. You kind of just have to, you know, look at the different ones. All right, so example 4. This one is different because this is a double angle. If we're solving the sine of 2 theta equals 1/2, and I put that little plus in there after the fact just to kind of emphasize that it's a positive 1/2. Now, maybe you recognize this, maybe you don't, I don't know, but you might recognize that the sine of one of those common angles is 1/2. Or maybe you want to just go ahead and do the inverse sine of 1/2. We get 30 degrees. And it's sine, the sine function. So it's going to be 30 degrees in this quadrant and this quadrant. 30 degrees in quadrant 1 is easy enough. 30 degrees in quadrant 2 is going to be 150. So a 30 degree reference angle. Sorry, I keep saying 30 degrees in quadrant 2, and I should be more precise, say it's a reference angle, 30 degrees. So that's the same as a 150 degree angle. this 2 right here is kind of a problem. We get, once we take the inverse sine, we get that this angle right here, this 2 theta, is 30 degrees. And that 2 theta is 150 degrees. So there's my 2 reference angles. So I've got that 2 theta is going to be that 30 degree angle in quadrants 1 and quadrant 2. So I have that 2 theta is 30 degrees and 2 theta is 150 degrees. I have to solve for theta. Remember, when you're solving for a variable, you need to get the variable by itself. We're almost there. By getting rid of the sine, by taking the inverse sine and finding the angle, I've now got this sine out of the way, and now I've got, okay, 2 theta equals 30. So I just divide by 2, just kind of like what you would do with normal equations, right? Divide both sides by 2, and I get 15 and 75 degrees. But here's where it gets weird. This 2 tells me that I need to look in 2 revolutions for my answers. And I'll show you how that plays out. And it comes as a result of this having to divide by 2 business. Now, we have this whole, 1575 business, right? Both of those we can agree are in that 1 revolution. Now, the 30 and 150 angles, so 30 degrees here, 150 here, those are coterminal to 390 and 510. All I did was add 360 to the 2 angles that I found in the first place, that 30 and that 150. So I took those 2 angles that I found originally and added that 360 to them and got these. These are outside of 1 revolution. They look like they're not going to work because they're bigger than that 0 to 2 pi. But when you set this 2 theta equal to these 2 angles and you divide by 2, look at my final answers. Those are very much inside 1 revolution. That's between, all 4 of these are between 0 and 360. So what I did was I tried to color code this for you in blue to show you that, hey, this 2 is telling you, okay, we get this 30 degree angle to start with. So we find our normal 1 revolution, right? 30 here, 30 here. Quadrants 1 and 2 because it's the sine function that's positive. Once you get those 2 angles, so once you have this 30 and this 150, we need to add 1 revolution to them. So this stuff is in the 2nd revolution. All right? But when I divide this by 2, my final answer ends up in that 1 revolution answer. It's kind of confusing, but I highlighted the big parts here. If there's a 2 here, this tells you you're going to have to add another 360 to these 2 answers. Okay. Similarly, if there was a 3 here, you would have to add 360 and then 360 again, because that dividing by 3 is going to tell you that within 3 revolutions, and then having to divide by 3 is going to pull all those answers back into that 0 to 360 range. All right, I got another one like that, so let's keep going. So this one is cosine of theta over 2 equals -1/2. Now I've already worked this one out, but so cosine theta over 2 equals -1/2. I'm hoping that this -1/2 right here is telling you a lot of good stuff. Okay, the 1/2 part for the cosine, I hope that you look at that and you're like, ooh, I recognize that as the cosine of 60 degrees is 1/2. If that's not one that you've memorized yet, that's okay. But remember, it is helpful if you've memorized those. If you haven't, then you go to the calculator, you take the inverse cosine of 1/2, and you get 60 degrees. So this is telling you that it's a 60-degree reference angle, and it's going to be in the quadrants. Oops, in the quadrants where cosine is negative. So the cosine's negative here and here. So we're going to need 60 degrees, reference angle here and here. All right, so if this is my 180 mark right there in the middle, 180 minus 60 puts me at 120, and then 180 plus 60 is going to put me at 240. Now, all this came from using cosine and the negative 1/2. I still need to work this in, but that happens last. Just like in the last example when I had the 2 theta, and once I got my angles, I just divided by 2. So here, let's say that you recognize cosine 60 is 1/2. And so we put those 60-degree reference angles in the quadrants where the cosine is negative. That's quadrants 2 and 3. So 60 degrees in quadrants 2 and 3. So we get this 120 and 240 business. This, I'm not going to highlight it just yet. So look at what happens. When I take theta over 2 equals 120, to solve this, now I've gotten rid of the trig part, so this is just, some variable divided by 2 equals 120. To get rid of this division by 2, I have to use the opposite of division, which is multiplication. So I multiply both sides by 2, so I get theta is 240. Over here, same thing, multiply both sides by 2. So if I take my other answer of 240, multiply it by 2, I get 480. Now here's the thing. 480 is outside of my 0 to 2 pi interval. So I'm just going to ignore that one. Remember how in the last example I had a 2 theta, and that 2 theta told me, hey, you need to look in 2 revolutions for your answers. Well, theta over 2, there's an understood 1 right here. This 1/2 is telling me I only need to look for solutions in half of a revolution. So just in that 0 to 180 business, I only need to look in half of a revolution for my answers. If you don't catch that, it's okay, because it'll work out over here. Okay. Now, one thing I haven't pointed out, you can check all of your answers by plugging them back into the calculator. So if you wanted to check 240 degrees, just do the cosine of 240 degrees, that's my theta, over 2, and that should be negative 1/2. And so we get, negative 0.5. The problem, though, is that this answer will check out. So if you check 480 degrees, it's going to check. It's just outside of this interval. It's just, so it's not a wrong answer, it's just an unnecessary one. We're just limiting our answers to just between 0 and 360, because if we don't, then we have an infinite number of answers for every single problem, and we're not about that life. We're not doing that. All right. Let's look at example 6, and this will be the last one. The remaining examples will be in the hybrid video. Okay, so if I'm solving this one, this very much looks like, you know how we would factor stuff and we get something like x plus 2, x minus 3 equals 0. And you would solve that by taking each one of those factors and setting them equal to 0 and solving them separately. I'm going to do the same thing here. So this is factored. Because of this 0, I can do this split. I cannot do that for any other number. That has to be a 0 in order for me to do that. It's called a zero factor property. So we know that once we split those up, then we can solve those individually. So same thing here. I'm going to split these things apart, and I'm going to look at them individually. So if I look at tangent theta plus 1 equals 0, so let's not focus on the sign just yet. Let's just do the tangent for now. I do need to move this plus 1 over. I'm trying to get that theta by itself. So my first step is to get the tangent theta by itself. So I'm going to subtract 1. So I get tangent theta equals negative 1. Now I'm kind of like the first couple of examples. Maybe you recognize the angle whose tangent is 1, and then it's going to be in the negative quadrants. So I'm hoping that you'll look at this tangent and say, oh, 1, that's 45-degree reference angles in the 2 quadrants where tangent is negative. If you don't recognize that as a 45-degree angle that's needed, then you have to take the inverse tangent of 1. Now I used 1 and not negative 1. I used 1 because I knew that would give me the positive angle that I needed. And then this sign right here, this negative, would tell me which quadrants to put it in, because 2 and 4 are the 2 quadrants where the tangent function's negative. If you went straight for the tangent of negative 1, you're going to get negative 45. It's going to go ahead and give you the answer that is down here in quadrant 4. In quadrant 4, because the domain restrictions for the inverse tangent are quadrants 1 and 4. So I looked at the positive 1 to get my reference angle, my positive reference angle here. And then this negative told me which quadrants to put it in. So putting that 45-degree reference angle in quadrant 2 gave me 135 degrees. Putting a 45-degree reference angle in quadrant 4 gave me 315 degrees. So you can see how just very heavy on chapter 7 and 8 this is. So that stuff that we learned in the first, for the first test is super important here. That we need that to kind of move on. You know, I need you to be able to say, hey, 45-degree reference angle in this quadrant is 135. 45-degree reference angle in quadrant 4 is 315. I need you to be able to find those pretty quick and easily. You can use your unit circle if that's helpful. You can use your calculator, of course, but I need you to be able to do those computations. Okay, that's just the tangent side. So because this is factored, that's just the tangent theta plus 1 side. So there's my 2 answers from the tangent theta plus 1 business. Now, coming over here to the sine theta minus 1 side, I'm going to do the same thing I did with the tangent. I'm going to get rid of this minus 1. I'm trying to get that theta by itself. So I add 1 to both sides. I get sine theta equals 1. If you go ahead and take the inverse sine of 1, you're going to get 90 degrees. That is your only answer. Think about the graph of the sine function. It only touches 1 once within that 1 revolution. I'm thinking of 0 to 360. I'm not thinking of all the other times it bounces up to 1. 1, 0, and, well, actually 0, no, 0 is going to have more than one answer. But 1 and negative 1, those are just going to have one solution to them. Because in 1 revolution, it's only going to touch it 1 once and -1 once. Same thing with cosine. So I went ahead and kind of wrote that down, kind of a little tip for you, that if you're solving sine theta being 1 or -1 or cosine 1 or -1, you're only going to get one solution out of that. Now for tangent, we know that's not the case because we just did a tangent with -1. That's because the tangent function has a period of 180, so we get 2 of those little tangent snaky deals, so that's why we end up with 2 of those. But the 1 and -1 for sine and cosine are really nice because you really can just go straight to the calculator and get that. How else would you do it? You could use the unit circle. You could use the graph of the sine function. That's typically what I do. I kind of just know what that graph looks like in my head, and I say, okay, I know that it's up here at 1 at that 90-degree mark. So, all right, well, the rest of these examples, so example 7 and onward, are in the other video that is listed in the hybrid portion. So that's going to finish part 1 for us of section 9.5.